Welcome to today's lesson, which is about the product of powers. The goal of today's lesson is that you can understand and explain the product of powers property. So let's look at two examples. Let's start with 4 to the power of 2 times 4 to the power of 3. And I'm going to expand these. 4 to the power of 2, so 4 times 4. And it's multiplied by, so I'm going to bring down the multiplication symbol here, 4 to the power of 3. And we can see now that we have a base of 4 and it's multiplied 5 times. 1, 2, 3, 4, 5. So it's 4 to the power of 5. And our original exponents were 2 and 3. So you don't multiply the exponents. When you're multiplying terms with exponents, you add the exponents. So 2 plus 3 is 5, and we have 4 to the power of 5 here as the equivalent expression. So let's look at x cubed times x to the power of 5. X to the power of 3 we could also say instead of x cubed. So here's x times x times x. We've got a multiplication symbol here, and then x. So we have, if we add up all of the x's, there are 8 of them, x to the power of 8, where x is the base and 8 is the exponent. And if we look at our original exponents, 3 and 5, 3 plus 5 is 8. So the product of powers property says that when you're multiplying two powers with the same base, you add the exponents. So when you have an exponent, in the example here on the left hand side, 2x to the power of 3, the exponent only applies to the part of the expression immediately to the left of it. So we have 2 times x times x times x there. Now in the second example, the exponent applies to what is immediately to the left of it, which is a term in parentheses. So here we have 2x times 2x times 2x, because the 2x is in parentheses. And we can write an equivalent expression for that. 2 times 2 times 2 times x. And 2 times 2 is 4, times 2 is 8. So we could write 8x to the power of 3 as an equivalent expression for 2x in parentheses to the power of 3. And for the third example here, we have negative 2x to the power of 3 times negative 2x times negative 2x. So we can rewrite that. We've got negative 2 3 times, and then we've got x 3 times. So negative 2 times negative 2, 2 negatives is a positive, that's 4 times negative 2. So we have negative 8 times x to the power of 3 as an equivalent expression for negative 2x to the power of 3. So the exponent applies to everything in the parentheses to the left of it. Here we have an algebraic expression, x cubed times y squared times x. And just to note that this x here doesn't have an exponent explicitly stated, but it is understood that it is x to the power of 1. And then y to the power of 5. And we can write an equivalent expression for this of x cubed times x to the power of 1. I'm going to explicitly state to the power of 1 times y to the power of 2 times y to the power of 5. and we can write an equivalent expression for that. The x and the y, x to the power of 3 plus 1 is 4, and y to the power of 2 plus 5 is 7. So when a number or variable does not have an exponent, as we saw just x, it means that the number is raised to the first power. That means x to the power of 1. An exponent only applies to the value to its immediate left. So for example, if we have 3x to the power of 4, the exponent only applies to the x, not to the 3. If you have 3x to the power of 4 with the 3x in parentheses, well then the exponent applies to everything in the parentheses. So you saw today, and hopefully you can now explain the product of powers property. And that's the end of today's lesson.